Hey guys, so this video is about applications of systems of linear equations or word problems, and I'm just going to go ahead and show you the three word problems that I'm going to go through. So these all might look really different, but in my opinion, these are all like very similar if you know how to read the problem. So first, let's just kind of read them together, and then we'll do them each separately. But the top of a rectangular desk is twice as long as it is wide. The perimeter of the desk is 180 inches. What are the dimensions of the desk? And then we have Sarah bought 3 shirts and a scarf for $53. Marie bought 2 shirts and 3 scarves for $54. Find the cost of each item. And then how many milliliters of a 5% acid solution and how many milliliters of a 17% acid solution must be mixed to obtain a 60 milliliter solution that is 15% acid. So the thing that I want you to notice in these problems is how they are kind of talking about two separate issues. And each one of those issues are going to be what determines one of your equations, because for a system, you really need to get 2 equations and 2 variables. So I just want to point this out before I jump into this. So notice that the first part of this is talking about dimensions of the desk. And then the second part is talking about the perimeter. So these are 2 separate issues. And so that's what's going to help dictate our equations. Now in the next one, we have some information about Sarah, and then we have some information about Marie. So there are your 2 separate situations. Now, the third one might be a little tricky, but if you read this over, so it's talking about really 2 things. One, it's talking about getting to 60 milliliters of a solution, and then it's also talking about that solution has to be 15% acid. So each one of these kind of has like their own situations, and that's one of the key things that you want to break out when you're doing word problems with linear equation or with systems. Okay, so now going to this first problem. So it says that the top of a rectangular desk is twice as long as it is wide, and the perimeter of the desk is 180 inches. So what are the dimensions of the desk? So really, if we declare a couple variables, so we'll have L be the length and W be the width. So let's focus on this first situation here. So the idea that it is twice as long as it is wide. So reading that sentence, it's twice as long as it is wide. So think about the math words in that. It's literally saying the width is twice as long as, or it is twice what the length is, right? So what that means then, the width, W, is, well, is would indicate having an equal sign. And the width has to be twice the length. So twice the length would be 2L. So there is one equation. And now let's think about the other one. The perimeter of the desk is 180 inches. Well, now think about how this perimeter of a desk would work. I'm going to have my length and my width. So to get to the perimeter, I'm just going to add up all the sides. And that comes out to 2W plus 2L. And what should this equal? 180. And so now look at what we have. We have our equations and we have a system. 2 equations, two variables, we're good to go. And actually, in this particular instance, with W equaling 2L, we can just use substitution here. So I can take this and I can just plug it right into that W there. So this becomes 2 times 2L plus 2L equals 180. So this is going to be 4L plus 2L equals 180. And that comes out to 6L equals 180. So if I divide both sides by 6, then my length is going to be equal to 30. And now to figure out the width, Well, now I can just take this information and plug it back into this equation. So if my W is 2 times the length, then my width must be 60. So this would be in inches. And so there's your answer. All right, so moving on to the next equation. So we already kind of broke this one down. So we talked about that we have this situation with Sarah, and then we have this situation with Marie. Now, in this case, we have shirts and scarves. That's really all that we're talking about here. So let's let X represent shirts, and Y represent scarves. So now I can pretty easily model their buying situation using these letters. So I've got 3 shirts and a scarf for $53. So 3 shirts will be 3X, and then 1 scarf will just be Y. And what does this have to equal? 53. And then for 2 shirts and 3 scarves for $54, well, now I use the same idea, right? So 2 shirts, that's 2X, and then 3Y equals 54. So now look, now I have that system of 2 equations with 2 variables. And now I can use whatever methods I want to finish this. So what I'm going to do is I'm going to use elimination. So I'm going to multiply this equation by -3 so that I have -9x minus 3y equals -159, and then this is 2x plus 3y equals 54. So now if I use elimination and I just add these up together, I get -7x equals -105, and then I can divide both sides by 7, -7, to get that x equals 15. So that's $15 for a shirt. And now I have to determine y here, so I can plug this back into the first equation. So let's see, I'll take 3 times 15 plus y equals 53. So I have 45 plus y equals 53. Subtract off the 45 to get y equals 8. And so that would be $8 for a scarf. Okay, so now for this last one, and this one's probably a little tricky if you don't quite know how to think about this, but what we're talking about here are 2 different things that we really want. So we've got these 2 solutions, and we want to combine them to get a 60 milliliter solution that is 15% acid. So in this case, let's think about the first solution being the 5% solution. And then for the other one, let's make that the 17% solution. Okay, so in thinking about this, the one thing that I need to have happen is I need to combine these 2 solutions to get how much solution? How much solution do I actually want? Well, I want this to end up being 60 milliliters total of solution. So this is some amount of the first solution, this is some amount of the second solution. But now we need a second equation here because we need to make sure that this solution is going to be 15% acid. So now what we're going to do is we're going to use these percentages to figure out how much acid is in each solution. So this means 5% of the solution is acid. So if I want to know how much of that solution actually is acid, what I'm going to do is I'm going to take that decimal, 0.05, times the amount of solution, and that will tell me how much acid there is there. And then for the second one, 0.17 times y, that'll be how much acid is in this other solution. And in total, what I need to have happen is I need 15% of, remember the word of means multiply, 15% of this 60 milliliter solution needs to actually be acid. So there's kind of the setup of the second equation, and that's how you can kind of bring those acid percentages into the problem. And so now from here, it's kind of the same idea. So if I multiply these things together, so let's see, I've got x plus y equals 60, and then actually just one thing I'm going to do over here. So I did 0.15 times 60, so that came out to 9. And so I've talked about in other videos how you can clear decimals. So if you want to get rid of the decimals, what you can do is you can move all of these decimals this way. And remember, if you do that for those two, you have to also move the decimals for 9. So everything has to be moved. So this will come out to 5x plus 17y will equal 900. And so now I can go ahead and solve this equation or this system. I'm going to use elimination here again. So let me clear a little space. And I'm going to multiply the first equation by -5 to get -5x minus 5y equals -300. And now I can go ahead and eliminate. So let's see, this will come out to 12y equals 600. And so then I can divide both sides by 12. And so that will be 50. All right, 50 what? So it's how much do you need of each solution, right? So we need 50 milliliters of the 17% solution. And remember, we need this to come out to 60 milliliters total. So if I plug this 50 into this other equation, so x plus 50 equals 60, and subtract off the 50, then this tells me that I need 10 milliliters of the 5% solution. And so that's probably the trickiest setup out of the three. But hopefully that gives you a little bit of perspective of how to read some of these problems and how to pick out your different equations. And so that's it for this one, guys. If you have any questions, you can always leave me a comment, and otherwise I'll see you guys next time.